All right, so welcome to our review. For our review, I'm going to mainly focus on chapter 4. Chapter 4 was very, very dense. It was a lot of sections, a lot of different things. So your exam test 2 is going to be chapter 4. Chapter 3, we covered some stuff, but it was very quick. It was just rational functions, meaning how to graph an equation that is made up of a polynomial divided by a polynomial. There's lots of steps, but it's very hard for me to grade that via online. So I'll focus mainly on chapter 4. So chapter 3 won't be on your test 2, only chapter 4. For your exam, it will be a multiple choice test only, but I'll have a separate assignment where I'll direct you to turn in your work. I want to make sure that you are putting in the effort. You're not just like going through the process and just lucky guessing. All right, so these are the problems that we're going to go over. They have a small highlight. I can also give you a quick list of it. I'll write down a quick list of it. And for those problems that I don't complete, or that aren't highlighted, you can finish and do for extra practice for extra credit. And it'll be 5 points extra credit if you turn in this completed chapter 4 test. So meaning if you complete this file, then you'll get 5 points extra credit on top of your exam score. Now we'll do some of them, but there's still some that you'll have to finish. But I think that with the problems we do today, you should be in good shape to go ahead and finish them. All right, so let's go ahead and begin. 1A. So 1 reads, let f of x equal 3x minus 5 and g of x equal x squared plus 2. Find the following. So first, it wants composition of f composed of g of 4. Well, by definition, we know that our first one is our function, and the function that we're going to plug in for x is going to be your whatever is second. So g of 4. So you can do this in pieces. You can first find what g of 4 is. And if we go through the work, my phone's ringing, I'm sorry. Did I lose you guys? Are you guys still there?
Yeah, we're still here.
I'm still there. I'm sorry, give me a second. My phone rang and it disconnected me. All right, so I guess I'll continue this way. If you can't hear me, just let me know via chat. I'll check it every so many problems. All right, so G of 4. Oh, right there. G of 4, let's plug in 4 into our function G. So this is our function G. Let's go ahead and plug in A4. So that we have 4 squared plus 2. 4 squared is 16, plus 2, we get 18. So we have G of 4 is 18. Now we can go ahead and our function, we have f of G of 4. Instead of G of 4, we can plug in what it's equal to, which is 18. So we can find f of 18. Now this is our function f. Each function has a name. And this just means we're going to plug in an 18 for our function. So that we have 3 times 18 minus 5. All right, let's find out 3 times 18. That's 54. 54 minus 5 gives us 49. And that would be our final answer. That's the answer you would want. So with compositions, you have to make sure you go through the proper nesting of each problem. Are there any questions about 1A? All right, let's continue with 1B. So this one, notice there's not a number, but it's the same idea. We have a function, and in that function, I'm going to plug in another function. So if I can erase my markings above, this is saying that we're going to plug in your G into your F. So we're going to take all of this for G and we're going to plug it in for every X. Now in this case, we only have an X, but there's a possibility that we can have multiple X's. All right, so let's go ahead and do that so that we have 3x, and instead of x, I'm going to plug in G, which is x squared plus 2, 3x minus 5. All right, let's go ahead and distribute in that 3. So 3 times x squared is 3x squared. 3 times 2 is 6. And then we drop down that minus 5. And then I combine like terms. I can subtract 6 minus 5. So that we have 3x squared plus 1. And that's 1b. Now another one, and you will see this for sure, is like your next part of 1D. This is called difference quotient. It's a very big deal in this class because it's something you'll see again when you go to calculus. So that's why we emphasize it so much. So when you see it in pre-calculus and calculus, if you're going that far, you will have seen it and it won't be such a challenge. Now, notice that for all of these, you're working with your function f of x. So let's recall what f of x is. F of x is 3x minus 5. Now, if it's helpful, you can do it in parts. You can first find out what f plus h of x is. F of x plus h. And then f of x, well, that's just your function f of x that we have here. That's just that. Or better yet, just that. So let's go ahead and find that first part, f of x plus h. So just so we're okay with the notation, this means plug in for x, right? So wherever we see an x in our function, we're going to plug that in. All right, let's go ahead and figure that out. F of x plus h, so for x, we're going to plug in x plus h. So we have 3 times x plus h minus 5. Let's distribute that 3 so that we have 3x plus 3h minus 5. And that is our x plus h that we're going to plug in. So let's go ahead and do all this work. So we first want to plug in what is f of x plus h? Well, we have that right here. That is 3x plus 3h minus 5. And then I want to subtract f of x. Well, what is f of x again? Well, f of x is right here, 3x minus 5. All of that will be divided by h. And when I'm grading your work, when I'm grading your problems, I'll also grade your work. So if you had a misstep, I can kind of give you partial credit for it. Now what we do here is we have to redistribute that negative since we're subtracting the entire function. So that we have 3x plus 3h minus 5 minus 3x plus 5 all over h. Now what's cool and how you know you're on the right track is things should start canceling out. And if they don't, then something funny happened and go back and check your work. So we see here that 3x minus 3x is 0, right? And negative 5 plus 5 is also 0. So that we're left with 3h divided by h. And our h's, we can divide them out to get 1. So our answer is just 3. And that's your difference quotient. That's your answer. When you see this again is when you do your limit definition in calculus. So in case you're going further, you have something to look forward to. It's the beginning of the course. All right, you are left to do C and E. All right, 2. How do we know if a function is an inverse? So we learned a pretty cool equation that helps us determine if it's the inverse. If a function is inverse, composition of both functions equals x, meaning f composed of your f inverse of x will result in x, and vice versa. F inverse composed of f of x is equal to x. So that's how you can go ahead and test that 2 functions are inverses. Their composition is equal to x. 3a, find the inverse of each of the following functions. For a, we have f of x equals negative 3x plus 5. Okay, well, we have a set of steps that we can follow to find the inverse. Our first step is to change your f of x to a y. So replace f of x with a y. Next, you want to interchange x and y. Third, you want to solve for y. And lastly, you want to replace y with the inverse notation. So f inverse of x. So we show its inverse. Now, one initial step that must happen before we do all of this is to make sure that it's 1-to-1. If it's not 1-to-1, then when we can start going through the process, but somewhere in between, we might get stumped and we'll be like, hey, why can't I move forward? Maybe that function is not 1-to-1. Meaning that there's only one x point for every one y point. And it needs to pass both the vertical and the horizontal line test. So for A and B, yes, they're 1-to-1. So let's go ahead and find their inverse. So our first step is to replace our function notation with y. So we have y is equal to negative 3x plus 5. And then we want to swap our x's and y's so that we have x is equal to negative 3y plus 5. Our next step will be to solve for y, meaning let's get y by itself. Our y is right here. We need to undo all that work. So we need to move that 5, so we subtract 5 to both sides. And we're left with x minus 5 is equal to negative 3y. All right, our last step to get y by itself, let's divide by a negative 3. So I have y equals to x minus 5 over negative 3. And we were able to find the inverse. That's our answer. Last step, let's just change that y to inverse notation. So I have f inverse of x is equal to x minus 5 over negative 3. All right, let's go on with 3b. Same process. We want to start off by changing that that function notation to a y. So I have y equals x plus 1 cubed. All right, next step, I want to swap my x's and my y's so that I have x is equal to y plus 1 cubed. Now I want to go ahead and solve for y, meaning let's get this y by itself. So I need to undo that exponent of 3. So if I have an exponent of 3, we go ahead and take the radical of that exponent. So we take the cube root of both sides. Now, we don't need plus or minus. We only use plus or minus when I'm taking the square root or the fourth root, whenever it's an even root. So that makes it so that that exponent of 3 and that cube root cancel out. They're mathematical opposites. We're left with the cube root of x is equal to y plus 1. And last piece, to get y by itself, let's go ahead and subtract 1 to both sides to get 0. So that we have the cube root of x minus 1 is equal to y. And that's our answer. Let's just go ahead and replace that y with an inverse notation. So I have f inverse of x is equal to the cube root of x minus 1. For A, graph the following functions. Okay, so we want to graph this problem and we see that we have an exponential equation because our x, our variable, is on the exponent's place. Okay, so we know that these logarithmic and these exponential equations, they look like funny L's. That's how we think about it. They have an L shape to their graph. My advice is to recall where your asymptote is and then graph 2 points. You know it's an L shape, you can kind of figure out which way it goes. And if you're ever unsure, you can always plug in more points. That's what's cool about these functions, is if you know the shape, you only need a couple of points to figure out which way to go. So let's do a chart so that we can have a bit more guidance. So this is y is equals to 1/3 with the x exponent. So that we have an exponent of, let's do a negative, a 0, and a positive. So -1, 0, and 1. Okay, let's go ahead and work this out. So if I plug in a -1 for x, we have -1/3 raised to -1. So that means my exponent is a -1. I need to make the exponent positive. Let's flip my fraction so that I have 3/1. To the first power, that's just 3. Okay, what about 0? 1/3 raised to the 0 power. Anything to the 0 is 1, with the exception of 0. So 1/3 to the 0 is 1. And then we have 1/3 raised to the first power. If it's raised to the first power, it's just itself. So this gives us the points of -1, 3, 0, 1, and 1 and 1/3. Let's go ahead and graph those points. All right, so I have -1 up 3, 0 up 1, and 1 1/3. So this would be our L-shaped figure. And if you recall, logarithmic functions, if you recall your notes, logarithmic functions have a horizontal asymptote, and that varies if I have a plus number. So whatever that plus k is in your function will move your horizontal asymptote up or down. So here, even though I know we don't need it, I will draw it. We have a horizontal asymptote at y equals 0. Just so when you see horizontal asymptotes in your quiz or your exam, you won't think like, hey, where are those coming from? Why are those numbers coming from? They're from the idea that logarithmic and exponential functions have asymptotes. Exponential functions have a horizontal asymptote. Let's go ahead and continue with C. So here we have a logarithmic function. We have y equals, or f of x equals log of base 3 of x. Okay, so logarithmic functions are also L-shaped, but these logarithmic functions have a horizontal asymptote. Now, if you're unsure, I don't think I talked about this in the lecture, but if you ever get stuck, you can go ahead and rewrite it, right? So if you rewrite it to exponential form, wouldn't this just be 3 to the y power equals x? So it kind of is an exponential function in disguise, in case you get stuck. But that's not how we teach in the lecture, I think. I think we think about what is a log value. So we work with those basic values. So we have 3 to y power. What if we want an x of 1? Or how do we do in the lecture? We think about the answer. So 3 to what power? Which will be our y. Or, so this would be our y and this would be our x. So if we want a y of 0, then my x has to be 1. And if we want a y, an x of 3, my y has to be 1. So we already have points. I have an x of 1 and a y of 0. And I have an x of 3 and a y of 1. Since this comes from your logarithmic function in exponential form. And you really only need 2 points because they all look like this weird L shape. And I say weird because it's not an L. It could be a backwards L, or upside down L. All right, so I have 1, 0, and 3 up 1. So our graph looks like this. And logarithmic functions have a vertical asymptote. So here I have a vertical asymptote at y is equal to 0. Now, unlike exponential functions, the vertical asymptote in your logarithmic function comes from your argument. So if I have something along your x, then it causes that vertical asymptote to change. Okay, let's go to 5a. Convert the following to exponential form. This is so important. If you get stuck in logs, I think if you go back to this basic understanding, it's so helpful. So we understand, or if you recall from your notes, exponential form and logarithmic form, we can go from one another. So if I have log base b of a is equal to c, it's the same thing as b raised to the c power equals a. So if you kind of get confused, you can always think of it like a puzzle piece. Each puzzle piece, you can just move it and replace it with an appropriate place. So your base, your exponential base, and your logarithmic base are the same numbers. Now, the other workings of your C and your A, they kind of flip, and that's how I think about it. Your base is the same, but your exponent and your argument, they're the ones that flip. All right, so to begin, number 5, we want to convert to exponential form. We have log base 2 of 64 equals 6. So our base is 2. Now my exponent will now be 6. And 2 to the 6th power is 64, just like our statement says. And that's all you're doing for these. 5b, we have a base of 1/3. And now I'm going to switch my order. So I have an exponent of -2, and my answer is 9. Sorry about that. And that's what those problems, what they do. Number 6, combine the following to a single logarithm. So for this, you want to recall on your 3 rules of logarithmic equations. So I'll try to write them. It's really nice to have them handy. So maybe if you have a paper around or a Post-it, write them down with me so you have them with you for your exam. Our first rule is our, I don't remember if it's called sum or power rule, but the idea is if I have a log base b of a plus the log base b of c, if they have the same log base, then I can go ahead and write it as one log and multiply their arguments so that I have log base b of a times c. So instead of writing it with 2 logs as addition, I can write it with 1 log and multiply their arguments. Our second rule is similar but with subtraction. So if I have log base b of a minus log base b of c, I can write it with 1 log if they have the same log base. But instead of subtracting it with 2 logs, I can write it as division with 1 log. Division with the first divided by the second. So a divided by c. And lastly, 3, I think this one's called the power rule. And this says if I have a number in the front being multiplied of log of something, I can write it as an exponent so that I have log base b of c with the exponent of a. And I can interchange that however you see fit. Now, as you see, one of them is longer, one of them is more condensed. So for 6, it's asking us to combine the following to a single logarithm. All right, when I can use my rules of logarithm that we have above to make that happen. So let's go ahead and begin. Let's look at this first problem. We have log base 2 of x minus log base 2 of y plus log base 2 of z. I want to start by taking those first two, and I see that they have a log base 2, and I want to write them with one log. So I have log base 2. Because we see that they're being subtraction, I can interpret that as division. It'll be divided by first, divided by second. So x divided by y. And that's my first part. Now let's just go ahead and bring this down and see what we have. Plus log base 2 of z. All right, we see we have the same log base. So I can rewrite it as one log using that first rule. I can multiply it in. Now if I multiply it in, I'll have log base 2, and I'll have x over y times z. And you can go ahead and multiply that in. You can think of z as z over 1, and then how do you multiply fractions? You multiply across. So we have x times z, log base 2 of x times z divided by y times 1, we just get y. That is our answer. Okay, let's go on to b. We have 3 log b of x minus 5 log b of y. Okay, well, I need to, well, my goal is to write it with one log. Those 3's and those 5's are kind of in the way. Is there a way where I can get rid of them or change the position? Yeah, right, by the third rule, this tells me I can change it so that it's now my exponent. I can move the 5 so that it's now the exponent. So that I have log base b of x to the third power minus log base b of y to the fifth power. Okay, that's getting us closer because now I just have the logs, and I see these logs have the same base. Now, if they're logs and they have the same base and they're being subtracted, I can write them as one log by our second rule. I can write them as log base b over first divided by the second number. So I have log base b of x to the third power divided by y to the fifth power. And there we have it. Solve the following logarithmic equations. Now these are tricky. Well, not so much. What makes it tricky is that I think the last 3 sections of our log chapters were kind of working and dealing with these types of situations. And every single situation is different. It just depends on what we're working with. So we really have to give ourselves the time and the patience to kind of work it out and see what we can do. All right, so for the first one, we have log base 2 of x minus 1 equals 3. I don't know what to do. I'm kind of stumped that x is in the argument with logarithm. Maybe if we write it in exponential form, I can make sense of what we have, right? So let's go ahead and rewrite it in exponential form. So that's like our example. I think it was problem number 5 where we just had to rewrite it. Let's just rewrite it. This would be 2 to the third power equals x minus 1. Okay, can we do that? Yeah, that's something we can do. All right, now let's go ahead and work it out. So 2 to the third power, 2 times 2 times 2, that's 8. I was gonna say 6. That's 8. So I have 8 equals x minus 1. Now our goal is to solve for x. So plus 1, plus 1. So we get x equals 9. And that's our answer. Now, one annoying thing that you must do for logarithm equations is you have to check them. Because remember, your argument in your logarithm, whatever you have inside, it needs to be positive. And also the argument needs to be true. So those two conditions need to hold. So I have log base 2 of 9 minus 1 equals 3. Log base 2 of 8 equals 3. And yeah, that holds. 2 to the third power equals 8. So that's true. So just in case if you're working through your problems in your exam, if one of your answers is not showing up as a possibility, maybe it's because it didn't check out. So just be aware of that. Let's take a look at B. Now this one has way too many logs. But recalling my log rules, my 3 log properties that we just did, I know I can rewrite this as 1 log, right? So this can now be log base 6 of x plus 3 times 4 equals log base 6 of 2x minus 1. So I combined it as 1 log because they're being added. So I can multiply the arguments. Okay, so if I multiply them, I have log base 6. Let's distribute that 4 in. 4 times x is 4x. 4 times 3 is 12. All right, what do we do now? Okay, so we have to recall what we learned from our sections. If I have a log equal to a log, then we can go ahead and drop them. So we can disregard our logs. So that we have 4x plus 12 equals 2x minus 1. And then solve from there. Not so bad, right? But do you see how each one is different? And it's just a matter of seeing where we get and how to pull something from out of our hat, from out of our mathematical toolbox to be able to continue. All right, so let's go ahead and solve for x. So we have minus 2x minus 2x. We're left with 2x plus 12 is equal to negative 1. Subtract 12, subtract 12. We have 2x is equal to negative 13. Divide by 2, divide by 2, x is equal to negative 13 over 2. And that's B. And I think B won't work. I think B will produce a negative and thus be a false solution if you check it. I'll let you check it on your own. Okay, let's go on to 9. For 9, I'm doing A and E. All right, for A, solve the following exponential equations. So sometimes when we're trying to solve for the exponent, I can't move forward. But we can use that third property of logarithms, take the log of both sides, and that way bring that exponent down. And we'll see that in E. Now for A, I have 2 raised to the 3x minus 1 equals 32. Now the way to go around using logs or bringing in logs into the argument is to rewrite it so that you have the same base on both sides. Because if I have the same base on both sides, I can disregard the bases and just work with the exponents. So is there a way to get 32 from a base of 2? 2 to what power gives you 32? And you can take a moment and kind of play with your numbers. So 2 to the 6th power doesn't work. 2 to the 5th power, that works, right? So 2 to the 5th power is 32. So let's go ahead and replace this 32 with 2 to the 5th power. So now our problem reads 2 raised to the 3x minus 1 equals 2 raised to the 5th power. And that's cool. That's very helpful. Now that I have the same bases, I can kind of get rid of them and work with my exponents only. So that I have 3x minus 1 equals 5. And we can solve for x from there. So we do plus 1, 3x equals 6, divided by 3, x equals 2. And that's how we work with these type of problems. If I can somehow get the same base, it works to your benefit. Now I'm going to do E. And maybe I should have given myself more space for E. All right. Now if you look at E, if I look at 2, from 2 raised to 3x plus 2 equals 3 raised to the x minus 1, I can't rewrite 3 and I can't rewrite 2 so that they have the same base. So how do we go on from there? Well, when you're stuck and you just can't get the same base or force the same base, we can take the log of both sides so that we have log of 2 raised to the 3x plus 2 equals log of 3 raised to the x minus 1. And that's how we can do it. Now, why did we take the log? Well, according to our third property, I can go ahead and take that exponent and bring it forward, right? Just like I used it the other way around, where I had that leading coefficient and I rewrote it as an exponent. So that we have 3x plus 2 of log of 2 equals x minus 1 of log of 3. And that's how we can go around. Now, log of 2, log of 3, these are just numbers. They're very, very ugly decimal numbers, but they're still nonetheless numbers. So don't let that throw you off. Treat them as you would numbers. Okay, so if I'm going to treat them as I would numbers, I would go ahead and distribute. So let's distribute this log into our parentheses. So that I have 3x log of 2 plus 2 log of 2 equals, let's distribute this number, that is log of 3, x times log of 3 minus 1 log of 3. 1 times log of 3, so it's just log of 3. Okay, now our goal is to solve for x. So I need to get x on the same side. So let's go ahead and move this x log of 3 so that I can move it to this side. Now I can't really subtract or add them, but I can write them next to each other. Let's also move this other number out of the way, minus 2 log of 2. All right, it got kind of messy. Let's go ahead and rewrite it. So we have 3x log of 2 minus x log of 3 is equal to, on the other side I have negative log of 3 minus 2 log of 2. Okay, now our goal is to get x by itself. So let's go ahead and factor out an x. So I have x, and I'm left with 3 log of 2 minus log of 3 is equal to negative log of 3 minus 2 log of 2. Now remember, our goal is just to get x by itself. So let's divide. So I have 3 log of 2 minus log of 3. I have x is equal to negative log of 3 minus 2 log 2 divided by 3 log of 2 minus log of 3. And there we have it. It's a lot of work, but I feel like these problems are so rewarding because you kind of I don't know, when I would do them and I was in your place, I would think, whoa, we really are college algebra students. We know so much. And these are tricky. These are probably like the hardest problems of the chapter. But with practice, if you did your homework, you feel more comfortable with it. All right, last one, 10. Suppose that you invest 4,000 into account for 7 years at 3% interest. A, what is your balance if the interest is compounded monthly? And B, what is your balance if the interest is compounded continuously? All right, so for A, we need to recall our compound interest formula. So I can't remember from the top of my head. Let's see if I can. A is equal to 1 times 1 plus, well, this one's a quick Google search away. I wasn't far off. R over N raised to the N times T. All right, so let's go ahead and highlight these pieces. So for A, we want to find A. Now our P, our starting amount, is our principal. It's 4,000. So P is 4,000. R is your percent. We have a percent of 3.5. But remember, you always have to change your percents to decimals. If you don't, you're not going to get the right answer. So let's move it to the left twice. So I have 0.035. That is our rate. Now I need N, meaning how many times they're going to be accrued, compounded. So our N, our question reads, what if it's compounded monthly? Our N would thus be 12. And lastly, for our variables, we need T. T is time in years. Time in years. So that is 7 years. All right, let's go ahead and figure this out. So A is equal to P. P is 4,000. Forgot an extra 0. Of 1 plus our rate of 0.035 divided by our N. Our N is 12 raised to the 12 times 7. All right, so I always punch it in pieces into my calculator for the fear of getting a slight calculation mistake. So I have 4,000 of 1 plus, let's figure out what 0.035 divided by 12 is. So 0.035 divided by 12, 0.0029. And then 12 times 7 gives us 84. Okay, let's figure this out together. So I have 0.035 divided by 12. I just want that big decimal again in my calculator. All right, plus 1. We have to add the 1 first. And then I want to raise it to the exponent of 84. So exponent 84, we get 1.227. So I have 4,000 times 1.2771, and it continues. Last piece, let's multiply it by 4,000. And our answer is 5,108. And we want cents, so we only want 2 decimal places. 66. So my best advice, whenever you work with something that has a formula, take the time to label what each letter is. A is your answer, what your final amount is. P is your starting amount. R, well, what is R? R is your percent. And what is N? How many times it's compounded? And T, what is T? Time in years. All right, B. B is my favorite because it has that cool word. B reads, what is the balance if the interest is compounded continuously? So for continuously means it's compounded like every day nonstop, right? Now, at some point, it reaches a limit and you won't get past that maximum amount. That formula is A is equal to P E raised to the RT. And the reason why I remember this one easier is because it just made up a word for it. It's A equals PERT. PERT is not a word, but that's how I read it and that's how I remember. Okay, so we need to find P, R, and T. But we already have P, R, and T, and E is just a variable. So our answer for this one is our P is 4,000. E is the value E in your calculator. And we'll have R times T as your exponent. Our R is 0.035 and our T is 7. Okay, you can multiply those together if you want. And then from here is just calculator work. So make sure to do this first. Maybe you can even find that decimal first. So I have E 0.035 times 7. It's 0.245. So make sure you know where you find E in your calculator. So I have E of 0.245. Find the answer, which is 1.277. So I have 4,000 times 1.277. So times 4,000. Our answer is 5110.485253. But we're dealing with money, so we want to round. 5110. So 5,110 and 49 cents.
I have a question for number 11. Is it asking how long would it take to double, and with that triple on the bottom, is it asking how long would it take to triple as well?
Yeah.
Okay.
So it's 2 parts.
Thank you.
No problem. All right. So that's it for your chapter 4 test. You are going to have a multiple choice test. And with that, I'll also create an extra assignment where you turn in the work for it. Now, if you complete this entire file, which we did majority of it, you probably did like 60, 75% of it. If you complete it fully, I'll add extra credit points to your exam, because I feel like if you can just take the time to do all these problems, then you'll be in really good shape and it'll help you do well on the exam. So at the end, you get a lot more from it than just 5 extra points. You'll get a much higher score in your exam overall. All right, any questions before we finish? I'm going to go ahead and stop the recording.